Hello everyone, and welcome to NSTA Web Seminars, where you can find live interactive learning at your desktop. Today's seminar is titled Contextualizing STEM in the Science of Food. Our presenters are Deborah Spielmaker, Val Bays, and Sarah Young. Our teacher panel today includes DeEtta Anderson of Iowa and Denise Scribner of Kansas. My name is Ruth Hudson, and I will be moderating today's program. And now I'd like to introduce our presenters. Our InterAgtion experts are Val Bays, Sarah Young, and Deborah Spielmaker. InterAgtion teachers are DeEtta Anderson and Denise Scribner. I'll turn the program over to you, Deborah.
Thank you, Ruth. We're going to begin the program. As you can see, we've got quite a few presenters, and as each of us get to our section, we'll introduce ourselves. I am the director of the team lead of the National Center for Agricultural Literacy. It's the logo there in the bottom of the slide. And I work at Utah State University in the area of agricultural literacy and with graduate students who work in career and technical education. But this particular presentation, Contextualizing STEM in the Science of Food, we're going to try and highlight how STEM makes, and agriculture makes it easy to cover those concepts because of its integrated approach. So first thing that we want to find out is a little bit more about you. What state are you from? Some of you have already had that clip in there. And then what grade level do you teach? And what best describes the community where you work? This will help us hopefully as we go through to kind of tailor our comments. So I think it needs to go back to Ruth now so that she can do this poll for us.
Absolutely. Thank you so much, Deborah. So we're going to actually break this up into three parts. First, we want to know what state you're from. And so if you could access that clip art tool again, it's at the bottom of the toolbar. It looks like a mountain and a moon. And choose a common symbol, and please stamp on the map where you're attending from. And remember that once you place your clip art, if it's not exactly where you are from, you can always move it around. And so I'll give you about 15 more seconds to place your clip art, and then I will I'll turn it back over to Deborah so that we can move on to the next slide. If you're outside the United States, please type in where you're from in the chat window. All right, Deborah, it's back to you.
Okay, well, that gives us a sense of the geography, and the next question is, what grade level do you teach? We advertise this particular webinar as a high school, but certainly middle school and elementary are welcome to see how this fits in and contextualizes, but we'll be covering concepts primarily for secondary educators. But if you could go ahead and maybe Ruth can guide us through this poll.
Absolutely. I've gone ahead and enabled the poll, and so everyone actually has access to the polling buttons, so you don't need to put this in the chat window. You should have polling buttons on your devices, and that actually helps us get a more accurate poll. So what grade level do you teach? A, K through 5, B, 6 through 8, C, 9 through 12, or D, other. And so if you could go ahead and use that drop-down menu and tell us where you're from, or I'm sorry, tell us what you teach, I'll give you about 15 more seconds, and then I'll go ahead and lock that poll. Okay, we still have people responding. Thank you very much for responding. It's really nice to see so many teachers here tonight. So if you're just joining us, we're using the poll button, and we're finding out where we're from, and I'm going to go ahead and lock those responses, and I'm getting ready to publish those to the whiteboard. And here you are, Deborah.
Okay, very good. It looks like there's this category of, I don't fit into this category, but looks like we actually have a pretty good balance and a fair number of high school teachers with us this evening. So, of course, if you have questions as we go along, feel free to ask them. We have lots of resources between the National Agriculture in the Classroom Organization and the National Center for Ag Literacy, and we're happy to share those out, but focusing our content tonight on the science of food. And Sarah Young, who's with me, worked on a great curriculum project with middle school teachers, in particular, the gourmet food labs, which she'll talk about later. And then Valdez has also worked as a high school teacher. So I think that together, our collective knowledge and the teacher panelists that we have, hopefully we can answer all the questions. And if not, looks like there's a discussion option inside of the NSTA website. So the final question about what describes you is, what kind of setting do you work in? What community do you work? Is it rural, suburban, or urban?
All right, thank you, Deborah. So go ahead and use the poll again and respond, A, B, or C, by using that drop-down menu. And we have 51 people tonight, 54 people tonight, I guess. And so I'll give you a chance to respond, as we have quite a few people that are attending. And again, everyone has access to the poll button. It looks like an A with a box around it, and it's right underneath your name to the far right. And so everyone should be able to respond to that, and we shouldn't need to use the chat window. I'll give you about 3 more seconds to respond, and then I'll go ahead and lock those responses. So I'm getting ready to lock the responses, and I'm going to publish them to the whiteboard. And it's all yours, Deborah.
Okay, thank you, Ruth. We have a fair number of suburban and urban, and a few checking in from rural areas. And that's actually very good to know as we're talking especially about a topic like agriculture. Everybody thinks that that is a rural type of concept. But the way we're going to frame this tonight by talking about the science of food, that's impacting everyone in all living situations in all communities at least 3 times a day, and of course all the other things that we get from agriculture, ranging from the towels that we dry ourselves off with to the soaps that we use, even to some of the lubricants that we would put inside of jet engines. So hopefully there's a lot of content here that will connect with your science curriculum that you do with students regardless of the situation or the setting that you're in. So we'll get right to the content for tonight. It's estimated by 2050 our growing population will require the equivalent of all the food grown in the last 500 years put together. That can sound kind of daunting and a little bit scary. Can farmers simply double their production to meet this demand? Bit of a rhetorical question there, and probably all of you are shaking your head. No, there's got to be some other kinds of things done. There's going to need to be some things done about waste. There's going to need to be some things done about energy. And yes, there'll need to be some science interventions here with technology and seeds and yields, but there's some other things that need to be considered. And that's kind of the big overarching question for how's that all going to happen. As you contextualize your science curriculum within food, I think you'll find that kids become really good problem solvers, and that's what we need. We need them to be able to solve this problem that's going to happen in their lifetime so that people can continue to live on this planet. And so with that big overarching question, you see up here where it says, I'll have to grab hold of this little, there we go, where it says farm to fork. We're actually going to work a little bit in reverse tonight. You may have heard this saying, farm to fork, but what we're really looking at to connect with students is fork back to the farm, because that's their experience. This is an interesting graphic, and I've made it available as some of the downloads. Send it to NSTA, and it'll be available as one of the downloads with the recording. But sustainable interaction, this is really a pretty large, complex picture of agriculture. And as you take a look at this, you'll see, oh my goodness, all of these little intricate kinds of things that are part of the consideration within agriculture. Starting at the top with politics and governance and how that all affects agriculture, and civil and security and food security. And over here, some more food security into these other domains of sociocultural, political governance. Down here at energy on the bottom at 6 o'clock, and over here on the far right, again, sociocultural. When the main actual system itself is occurring here somewhere in the middle with all of these different influential factors. So if I take a look and maybe try and simplify that just a little bit, what's your role in this food system? All right, so we have it a little bit more simplified: environmental, farming, economic, and social. And this is some of the complexity within agriculture that makes it such an awesome topic to contextualize your STEM, or your science, technology, engineering, and math, because all of those concepts are part of the solution or part of your role in this food system. There is a lot going on in this picture, and you could spend a great deal of time talking about nutrients and waste and water and seed and energy and sunlight and chemicals and so on, all of these different concepts. But I just want to put that out there as we begin our conversation, sort of look at more details related to particular areas of science curriculum. Getting just a little bit more simpler here, we're pulling out from that giant confusing graphic that was the first one that I put up, and trying to simplify that a little bit more and to get this text brought out so you can really see what you're looking at. But here we're talking about food and the transportation and waste and water, energy, money, economic, and of course the geography, how that influences this entire farming supply and demand for food system. So you can see right away that it's crossing the concepts of energy, economy, the food that we need, and of course our social security, not that way, but our social ability to be secure in the communities that we live in the socio-cultural arena. So these are very interesting things to take a look at and have students sort of diagram out and think about what's that relationship, what are those connecting words. In fact, if you do much with concept maps, getting them to do the connecting terms here so they really understand this system is something that you can do, especially with a high school or middle school student. So what's the role of science in the food system? If we have 7 billion people today, and we are estimated to go to 9 billion by the year 2050, I think you can see that science, technology, engineering, and of course mathematics, all the STEM concepts, are really going to be part of addressing that bigger question about the 9 billion. And as I mentioned before, your students are going to be crucial to this role, whether they choose to go at it from a production side, a food waste side, or anything in between, the processing side of food. So with that, where does science of food fit into the next generation science topics? They're actually here, I'll simplify it, and I'll ask you to use that little sticker tool again, and just take it out and start clicking where you think the science of food fits into the next generation science topics.
I've gone ahead and enabled the clip art tool for you, so those of you that are just arriving, just please place the clip art using the common symbols where you think the science of food fits into the NGS topics, and if it's more than one, feel free to put multiple clip arts on the page and move them around as necessary. Deborah, it's all yours.
What I was hoping to see happen here is happening. I think with just seeing that graphic, it becomes pretty obvious that there's really a lot. And I see some great check marks, something I'm not going to talk much about tonight. I think Val may mention it with one of the graphics she has at the very end, but space systems, how understanding things in space and global positioning systems and autonomous systems and how that might influence our ability to feed everyone on the planet. Look at that crazy, crazy graphic. All right, we've got that, I think, sorted out pretty well. If you look at the next generation science standards, this is something that we have discussed in each time that we've done an NSTA webinar, and this is our third one. Over here on the high school side, you'll see that some of the most important concepts that need to be covered are science in both the body of knowledge that represent current understanding of natural systems and the processes used to refine, elaborate, revise, extend this knowledge. Again, with the complexities I just showed you, I think that you can see that contextualizing agriculture inside of science is it's really easy. And it would be easy to be able to connect things that are maybe tend to be compartmentalized as biology or life science with things like physics and technology. And those things have been taught in the silos, and maybe if you've done anything with science and STEM, you understand that those silos have to be broken down because that's not the way science really works. And to solve problems, we have to connect those STEM concepts. The second little bullet here is science is a unique way of knowing. And there are other ways of knowing, but science is a unique way of really understanding the questions that we ask about the world around us. Science distinguishes itself from many other ways of knowing through the use of empirical standards, logical algorithms, and skeptical review. And I would add onto that constant skeptical review. That's the way that we start looking at things And I think we never totally prove something. We always are just looking for ways to disprove it. Science knowledge has history that includes the refinement of and changes to, and therefore ideas and beliefs over time are influenced by in this case, the nature of science. So I want you to keep some of these really important overarching concepts in the back of your mind as we go through some more detailed things related to agriculture and how it can fit into your classroom. One last thing here related to the next generation science standards that many of you have probably seen, this graphic here, practices, core ideas, and the cross-cutting concepts. This is considered the 3 dimensions of learning. And what we are hoping to do is giving students those skills by looking at perhaps one topic, but at the end they have the ideas of the practices or behaviors or skills that are transferable to other areas. Same with these cross-cutting concepts. Looking at the cross-cutting concepts, we're talking about patterns, similarities, the diversity, the cause and effect, the scale. These are concepts that are not just unique to one topic in life science or one topic in physical science, but go across those domains. And then the last one is those domains of the disciplinary core idea, where we're looking at those specific disciplines and how those, what have been typically siloed, have that interaction. And all together, that is the 3 dimensions of learning. And so be thinking about that as well as we go through tonight's presentation. All right, as an overview, science is a way of knowing. We focus on how we know, and then we can solve those problems. It sounds pretty simple, but one time I had Brett Molding asked me, what is the definition of silence, and there was of science, and there was a very long silence. But really, this simple way, a way of knowing, I think is something that we also have to just think about it in the most simplistic of terms as we look at very complex problems. So tonight on our journey, our way to knowing, we're going to look at it, science specifically through food ingredients, food processing methods, a little bit about farm production systems, and how those things all link together. And we also can address some of the things of careers as we go through, because I think it will become obvious when you look at that complexity of those images, those graphics I showed you previously, that there's got to be a lot of people thinking about agriculture and the food, clothing, shelter, and all those things that we use every day around us get to us. So careers is definitely something that we will have a little bit of a conversation around. In terms of the phenomena, another thing that's important in the next generation science standards, consider the questions from students, and that they usually start with a why do or how come. They're not things that are just factual, like how many, but more why do and how come. And there's so many of those different kinds of things in agriculture. This questioning about phenomena is the beginning of a student's way of knowing, all of our way of knowing. Why do, how come? And so with that, one of our first phenomena that we're going to take a look at is the phenomena of the flabby pizza. Now, I went to a conference this past summer and watched a couple of these videos. This is actually a competition. This is the 2017 first place winner in a food science and action contest held by the International Food Technology Society. And this mystery of the flabby pizza, I know that you're going to want to move on, but just watch 1 minute and 12 seconds. It's 3 minutes and 45 seconds long. But I wanted you to pause, hit the pause button, because we're going to come back on the back side with a question about what you think is going on, and we don't want you to get the answer first. So if you'll supply folks with that link so they can watch that 1 minute, 12 seconds of that video.
Yes, the link is in the chat, and just for buffering purposes, I'm going to set a timer for 2 minutes, and I'll come back in 2 minutes and turn the program over to Deborah. So your timer starts now. All right, according to my timer, it's been 2 minutes, so if you could please come back. Deborah's going to give us some more instructions as we move on. It's all yours, Deborah.
Yeah, the phenomena of the flabby pizza. Why did it go flabby? So let's see what you all maybe think went on, and I think most of you probably cringed when you saw the pizza go into the microwave. But what do you think is going on? So what science topic would we investigate to discover the observed phenomena? So if you want to take your little marking tool out and click where you think it is, of course you might be subject to peer pressure, but see where you think the issue lies.
And for those of you that are just joining us, the clip art tool is at the bottom of the toolbar. It's a mountain and moon. And please mark wherever you think that the phenomenon best fits. It's all yours, Deborah.
Okay, so we can kind of keep marking it. Now go back to your video and let's find out what really went on.
I've gone ahead and placed the video into the link again, and I'll set the timer for 3 minutes this time. According to my timer, it's been 3 minutes, so if you could please come back to the presentation. Deborah is going to share what we're going to do next. Deborah, it's all yours.
Okay, so if you back on that chart, some of you are clicking on a variety of things, and maybe you made some different connections. But one of the connections that you should have made was to the energy side, and I'm going to take a look at that in a moment. I did want to give you this little classroom tip on watching videos and being able to pause and ask questions like this, especially when it's related to phenomena. I used this Ed puzzle with a group of students, and it was a really good way to have an interactive pauses put into into video. So just a little side note that that's really useful with videos that you work with. But in our video, the case of the flabby pizza, those of you who selected waves and electromagnetic radiation, microwaves are really touched in this section, of course, energy, and I'm thinking a lot of you had different ways that you were connecting that content about the flabby pizza as you watched that video. But the reason I picked that one was that I also had another student who did a STEM lesson and had really misconceptions about how microwaves worked. And so it was a really good way to talk about microwaves and also introduce phenomena. All right, the science of food then. I'm going to turn the mic over to Sarah Young, and she's going to talk about some curriculum that she's worked on, and she's going to be able to share with you some of the resources that are part of a book that she prepared for NSTA related to gourmet lab or related to food science. So without much further ado, Sarah, I'll let you take this.
Great, thanks, Deborah. So my name's Sarah Young. I actually work for the Utah State Board of Education, but formerly was a secondary science teacher. And I'm excited to talk to you a little bit about Gourmet Lab. In terms of this particular resource, it really stemmed from working in a secondary classroom and trying to help my students make connections between some of these science topics that, you know, for me were exciting because I love science, but I was having a hard time engaging them with. So, you know, if any of you teach adolescents, you know the fastest way to their heart is food. And so it was a really great opportunity to work with them and look for opportunities within food to be able to highlight some of the different phenomena that really grounded and contextualized what we were talking about when we were looking at some of the different mechanisms that really kind of support and garner what's happening in the world around us. You'll note that there's free chapters available. As a teacher, we always appreciate free. And so if you, both links Ruth has posted over in the chat box. The first one will take you to Google Books. And you'll note that there's a couple of labs available there, Butter Battle, Exploding Corn, and Melting Apples. And then Experiment 9 talks about ballpark pretzels, which is what we're going to touch on first. But before I touch on that, if, again, you had an experience like I did as a new teacher, they really made sure that we were clear on safety in the science classrooms first. So with that kind of lens, when I was first introduced to this idea of looking at food science, I was really hesitant because I had concerns about the safety. My lab poster in my room said no food in the classroom, and so I was really going a different direction from that. So a couple of things just to note about the science of food. Safety is your number one, and if you look at either of the free texts that are available, you'll see that the section on safety is included in both of those. You really want to be thoughtful about how you're engaging with food, what materials you're using, and that you're doing it with an attention for safety. To be safe, I actually started the process using disposables, so like paper cups and things like that, and slowly but surely kind of built my my materials to be able to support this. When you're looking at the science of food, the other thing that I wanted to do as a science teacher was really highlight the science component of it. And so rather than it coming across as, you know, a really fun cooking lesson, I wanted them to start to make those connections. So you'll see in the labs that we use the metric system. We also use standard lab equipment. We use the scientific names for the different materials that we're engaging in. And these are things that you can do, honestly, with a simple cookbook in regards to being able to look at how am I making connections for my students. So for ballpark pretzels, the phenomena we're investigating here is really why are there air spaces in pizza dough? And so really linking back to the phenomena of the flabby pizza, it's a very similar discussion in regards to looking at fermentation of sugars, air pockets, and how are those created, and how does that create a different texture in regards to this particular lab. When you're asking yourself about that phenomenon, why are there air spaces in dough, this is a great one to do with students because we actually have them not just make the pretzel, but you can also do a wet mount slide under a microscope. And when you do that and you combine the materials in smaller quantities that you're using to create the ballpark pretzels, you can actually observe the creation of the air bubbles and the pockets and have students count those in regards to recognizing kind of a process that's happening that then leads to the specific texture that they expect when they're engaging with breads and other kind of gluten-based materials. So I would have my students go ahead and make the pretzels. We would make them and actually cook them in a toaster oven because that was a lot easier for me than trying to figure out how to get them to an oven. And all of that is included in the teacher section associated with this particular lab. In terms of looking at the creation of those bubbles, it then comes to those conclusions and connections. And I think this is really where drawing connections and explicit connections between phenomena and cross-cutting concepts is really important. It's a lot of great discussion that's going on as a teacher, asking questions about why are we adding this? What is the purpose of this part of the process? Why are we engaging in this procedure? What does the heat do? Gives you lots of opportunities to pose questions to students that can lead into additional discussions. Ultimately, they're invested because they're excited to eat their ballpark pretzel at the very end. And I taught, again, secondary students. They were very competitive. They wanted to have the best one. And so they had a reason to go and investigate some of this material because they wanted to create the best pretzel for the class. So the question I am going to pose is if you take your leftover pretzel from the ballpark home to reheat, later what type of heat will give you a similar eating experience? And hopefully, as you're contemplating that, that gives you a moment to start to consider how does that relate back to the flabby pizza discussion? And where are we making those connections that are relevant to our kids, to what they see in their everyday lives, so that these phenomena are really grounded in not just, as Deborah says, science is a way of knowing, but also science is the study of the world around you. And with that, I'm going to turn it back over to Ruth.
Thank you so much. We have some time now for questions. If you have any questions, would you please type them in the chat, and our presenters will be happy to answer them for you. And I'm just going to scroll down right now and see. We have some people that are typing, so I'm going to give them just a little bit of time to get their questions typed in. Sometimes it takes just a little bit to get those fingers moving.
While we wait for that, Ruth, I just want to say, Sarah, that's really good to connect those 3D, 3 dimensions of learning, being able to transfer that knowledge between all these different bread products, if you will. And we all know what happens in the microwave with different bread products. So it's something that they can use every day. It's relevant to them. And it really just makes sense, but you're still covering those science principles. So I think taking the pretzel and pizza and some other things could really work really well.
All right, thank you so much, Deborah. Val Bays wants to know how many lessons are in that book?
Great question. There's actually 15 lessons in the book. Each one starts with an introduction to create a context for the conversation. It has a complete student section, and then as well has a follow-up teacher section that translates what that lab looks like in everything from what do you actually need to buy at a grocery store, how do you scale it if you don't necessarily have all the resources in hand, and then walking you through kind of the lessons learned from an experienced teacher of doing this before, what to look for, and how to best support your kids.
Thank you very much, Sarah. We have time for one more question. So if you have a question, please type it in the chat window now. Renee has a question about the book as well. Is the book geared toward middle school or high school?
So the book was actually developed working with kids between grades 7 through 10. And so that's really what the focus is. In the teacher section, we give information about how you could modify it for an elementary setting, as well as how you could modify it for a high school setting or an honor setting as well, and take it up a notch.
Okay, well, thanks, Sarah. And then people, if you still have questions, you can type them here in the chat box, and maybe we'll come back to them, and certainly they'll be part of the discussion. But I want to get to the rest of our program. AgClassroom.org, this website, has a lot of other resources that you can search, and we're going to come back and talk about them a little bit later. Sarah's book was put together with the support of NSTA, and so that's, they've released, it looks like 3 lessons, and so that's what you have to get to the free part. But there are a whole bunch of other resources on agclassroom.org, and in that bottom left search box, if you typed food, you would find a whole list, and you can separate it by grade levels and so forth. But I'll talk about that a little bit more at the end of the program. Just wanted you to know that there's lots of different ways to get to resources, but that using food is a really great way to integrate these concepts. Also on our website, we have all these other teacher resources, and we're going to hear now from a couple of our teacher award winners. If I can move this slide ahead here. First, we're going to watch a video of Denise Scribner, and I think the link is posted. The Vimeo link is posted in the moderator's box or in the room box. So if you click on that link, you'll be able to watch one of our awesome teachers who does agriculture type work with her students in a high school setting.
All right, thank you, Deborah. I've gone ahead and put the link into the chat window. If you click on that, it'll take you to a Vimeo site. And the video lasts 3 minutes and 24 seconds, so I'm going to set a timer for 4 minutes to allow for buffering. And I'll see you back in 4. Nicole, you actually haven't lost sound. We're just pausing so that you can watch the video that's been placed in the chat. And we have about 2 more minutes where people are given time to view the video. And then if you have any questions, you can certainly type them in the chat window. So it looks like, according to my timer, we probably have about 1 minute left. And then I'll call everybody back to the room. So I'm hoping everyone can hear me. The timer has not gone off for the video, and so if everyone can come back into the room, you should be able to hear me speaking now, and if you can, just go ahead and type in the chat window so that we know everyone's okay and that they can hear me. And I'm going to turn it back over to Deborah.
So you just saw, if you clicked on the link, and we'll have a couple of more of these throughout the tonight's presentation, but when that hyperlink appears inside of the chat window, just click on it and hopefully it will launch a browser for you, and you'll be able to watch the video that we're referencing. But you just watched Denise Scribner and what she did with her students, which was quite an elaborate way to immerse her students in agriculture and get them thinking about some of the really big picture things, taking those concepts that they're learning and applying them into a real world setting. So if you have any questions for her, you can post them in the box. And I'm not seeing any right now, but Denise, do you want to make just a quick comment about how well this went so we can move on, and then people can type you questions as we watch Dietta's video next.
Thank you. The National Ag in the Classroom website provides you with standards that are a wonderful link to doing agriculture in the classroom that go hand in glove with next generation science standards, particularly if you teach an ecology class, zoology, or botany class. But you can also have science in everyday things. That's why we use the Outdoor Wildlife Learning Site on campus to prove the process of photosynthesis by taking the near CO2 monitors out in the parking lot, finding out that we have over 300,000 parts per million there, and then as they walk across the grass into our gardens, it plummets to under 300 parts per million. And then when asked what is the process, it took about 8 minutes, but then they finally remembered, aha, photosynthesis. So it's a great way to show that you don't necessarily have to grow plants that you have to harvest, because our harvest time is usually in the summer when school is not open. We did all indigenous plants to native grassland biome. So check out what grows in your area year-round and plant various gardens so that they bloom throughout the year, and it becomes a wonderful place for your community to visit. That's why we have the QR code nature trail, so that there's no littering with the pamphlets.
Thanks, Denise. That's a really good overview. And she did post in the chat box a link to her own personal website where she has a lot of different resources. So if you scroll up in the chat, you can see that. Also, there is a question posed there for you, Sarah, about is everything edible in that book? And I believe it is. But you can answer it in this chat window as well.
My classes also have Facebook pages, so if you're a Facebook user, just I put that up in the chat box as well.
Perfect. All right. Dietta Anderson is our other teacher that we'd like to feature, and she took a little different tack in her classroom. So if you'll go to her video link, which is inside the chat box, and just click on that link, hopefully you'll be able to step out and watch what she's done with her students, and then we'll come back.
All right, thank you, Deborah. I've placed that video link into the chat window. I'm actually going to turn my mic off for about 4 minutes and 30 seconds, so you won't hear anything, but you probably haven't lost sound. We're just letting you view the video in quiet because it's annoying when someone's talking when you're trying to watch something. I'll be back in 4 minutes. All right, my timer's gone off, and so thank you so much for viewing that video. If you could come back to Blackboard Collaborate, we'll hear what Deborah has to tell us next. Deborah, it's all yours.
Actually, I'm going to turn the mic over to Dieta so she can add on anything else that she'd like to about this. I'm actually intrigued by the energy things that you did with your students in Iowa and the alternative types of energy, but anything you would like to add on right now, and then of course if you have questions, type them in the chat box.
Okay, I don't know if I have a lot to add except that I do like alternative energy issues, and I'm a really issues-based teacher, so it's the science, technology, and society emphasis that I like to do, and I also like to do very much local issues. So if kids are hearing about giant hog confinement operation going up in town and they want to know more about it, we veer off in that direction. And, you know, I really take what the kids are interested in and move that direction. So if kids are interested in energy issues, we went the Bakken pipeline issue because they were very interested in that. So I really like to do things that involve kids thinking about being citizens in society. And I think Farm to Table is a perfect way to do that in all aspects. You can't lose doing that.
Okay, well, thanks very much. One of the topics that you just mentioned was the social issues, and socioscience could be the whole topic of at least 2 or 3 more webinars, but I'll think about that for another session. But if you all have any other questions for either of these 2 really exemplary teachers, just type them in the chat box, and we'll keep an eye on it. And of course, there'll be discussions afterward. Just moving on and going back to the agclassroom.org, if you type, she talked about different biofuels, and she is from Iowa, so if you go to that agclassroom.org site and you type a word like corn, you're going to find a lot of different lessons, and in this case, I didn't actually put in a grade level, but you could also put in different grade levels and fueling up with certain biofuels, adding perspectives about GMOs, obviously with corn. Corn, an amazing plant, and she had a section there about making plastic with her students, pests and pesticides, plant nutrient deficiencies, and this was all that would fit on the page, but there was quite a bit with just that one term because we grow more than 30% of the world's corn. And that segues really nicely into what Sarah's going to talk about, which is one of those other publicly available lessons inside of her book, Exploding Corn. So Sarah, I'll let you talk about this particular activity.
Great, thank you. So I think popcorn is just one of my favorites in terms of not just eating, but also having that opportunity to look at the science behind it and why is corn pop in the way it does. Anything else we normally throw into the fire doesn't have that type of reaction. So this is a great one to engage kids. And again, they have lots of family connections in regards to where they see it. If you look at it, we do actually present students with the anatomy of the corn kernel in terms of looking at the role the endosperm plays and with the pericarp and how it's actually the moisture content that makes a big difference in regards to the actual reaction you get when heat is added to it. There's lots of really great videos in regards to looking at a popcorn kernel popping in slow motion and having the students have that opportunity to see it, especially in slow motion, makes a really great and quick connection. I believe Ruth has posted a video in the chat box that actually shows that. I think in the interest of time, I'm just going to leave that for your viewing in the future. And then in regards to this one, I think the other part that I like highlighting with the popcorn lab is that I think a lot of times with food, we start to think about molecular structure and how some of those kind of chemical reactions are taking place. But this is a really great one that's just looking at the difference between mass versus volume. And so how do you start with something and kind of that conservation of mass from the popcorn kernels until the very end and yet have a pretty significant change in volume. When we were looking at it, it's a really great way to have that mass volume conversation without it being really bland and kind of lacking that context. So drawing it back to connection in regards to measurements and those different metrics in regards to food science is another just really great way for kids to be able to connect those resources to what they're seeing in the world around them. And with that, Deborah, do we just want to share this link and then keep going so that Val has plenty of time?
I actually think we're okay with this particular one. It's fairly short. As you can see when you get to 2 minutes, it talks a little bit about popcorn. I think if you'll publish the link there, we have plenty of time to watch this really interesting thing about how popcorn gets put in the bag.
Wonderful. Thank you very much. Go ahead, Sarah.
Nope, that sounds great. Go ahead, Ruth.
All right, I've gone ahead and placed the link into the chat window. Could you turn your mic off, Sarah? Thank you very much. Take about 2 minutes and watch it. It'll show you some really great things about how they get popcorn in a bag. And I'll set the timer for 2 minutes. It'll get you about halfway through the video, and then we'll come back. All right. We have spent 2 minutes and 30 seconds watching a really amazing video, and I'm going to turn it back over. So
I think that you found that that was not only how the temperature that has to take place inside of the kernel, but also the technology involved in making sure that we all get perfect popcorn. So something that's really familiar, we've talked now a little bit about the science concepts, we've talked a little bit about the food processing and looking at some of the activities in the gourmet lab, some other things that are on agclassroom.org. And now we've taken that farm process, and now we're going to take it and go back to the farm. But before we do that, are there any questions that we can answer so far from the audience before we start looking at really how all of this relates back to the production side of what happens on the farm?
If you have any questions, go ahead and type them in the chat window at this time, and I'll read them to our presenters, and they can answer and help you out to better understand the processes that they've been explaining, because we have gone through a lot of information. I'm scrolling down. It looks like there are some people that are typing, so I'm going to give them some time to type. I'm scrolling back up. Rebecca has a question that I will read to you. I'm in a credentialed program in Los Angeles. I imagine that your students in farming communities have pretty extensive background on ag topics versus my future students. Thoughts on building background for urban populations? I'll turn it over to you, Deb.
I think you might be referring back to the teachers that we have, one from Kansas, one from Iowa, that had really those types of settings. But then bringing it back into the classroom, if you take a look at how you connect with what Sarah presented in terms of the popcorns and the pretzels and those sort of things, you can relate that, and that's the point. Relate their experience, their point of entry to agriculture is a bag of corn chips, which quite honestly is our next slide. That's their point of entry for agriculture. But then leaping off and going back almost with a concept web within our mind, how does that get all the way back to really the soil, the sun, and the fact that it rains or water? And so that's their point of entry. The idea is to get them in their point of entry, but there are agricultural issues going all around. And in fact, you can keep typing some questions. I hope that helps, and if not, you can post something else in there. But at the bottom of these chip bags, you oftentimes see different logos or labels. Some things like on this one here on the right, no MSG, no trans fats, no gluten. These bags may be familiar to you, USDA organic. What in the world? All these logos on a bag of chips. This is the point of entry that students will have and where you can kind of leap off from in answering their questions. And within those questions, you're going to get into those concepts of phenomena. So I'm going to turn the time now over to Valdez, and she's going to just kind of look at some of these labels, but then get into the science, the production side of science that actually builds up these labels.
Hello, can everyone hear me? My name is Valerie Bays, born and raised in St. Louis, Missouri. My background is in biological science. I went to the University of Missouri-Columbia. I also have a master's in education and spent a little bit of time in the classroom. I currently work for a company, an agriculture company called Monsanto, and my role there is to do education outreach, so taking our scientists and engineers into the classroom and attending conferences like the National Science Teachers Conference. So I don't know about you all, but when I walk down the aisles of the grocery store, sometimes it can feel really overwhelming. I have a friend who jokes that it's like NASCAR for food. So and explain the purpose of a label, which will help us differentiate between what is scientifically accurate and what is a marketing tactic. So over 100 years, the FDA, which stands for the Food and Drug Administration, has regulated information on labels under the authority of a certain act. That act is called the Federal Food and Drug and Cosmetic Act. These labels must be truthful and not misleading. The USDA, which stands for U.S. Department of Agriculture, Food Safety Inspection Service, regulates labels for meat, poultry, and eggs. However, things like alcohol, tobacco, food supplements, have a separate labeling requirement. And there are some parts of a food label which are mandatory, like identifying the food, the ingredient statement, the amount of food in the package, the name, the place of business, and the nutritional content. It must have a common name of the food product, or its standard name, and it must be placed on the front in a certain way, and it should stand out. And the second piece is the ingredients listed. So the ingredients are listed in descending order of predominance. And again, the common names of the ingredients are used. Each of the names have a specific size, and then the nutritional facts have to be in a box. So many of these required labels have specific details. And I think that we can all agree that there's a lot of value to this required information. If you're a diabetic, it is important to know the sugar content. If you're allergic to eggs, it's important to know if there are eggs in the product. And now that we know a little bit more about how the government mandates these required labels, we're going to talk a little bit about some of the common terms that are voluntary. So we'll get into that in just a minute. Let me find my slide advancer. Okay, so there are many labels here too that I'm sure you've seen on some of your food packages. Now, I don't know the specific parameters of most of these fields. For example, it's hard for me to understand how animal welfare is measured or if it is measured and what would warrant an animal welfare approval seal. And I'm not too sure how humanely certified is measured, but I do know that every single farmer and rancher that I have ever had the opportunity to meet or visit their farm humanely raises and handles their animals. And for that matter, crops, really. because at the end of the day, it is their livelihood and their family's livelihood which is dependent on making sure that those animals and crops are well taken care of, healthy, and make it to market. Now, for the seal that you can see there in the upper left corner, that is the USDA, again, that stands for U.S. Department of Agriculture, organic seal. And the USDA organic standards were implemented in 2002 based on the 1990 Organic Food Protection Act. And it was really established because they needed a national organic standard instead of kind of individualized state standards. Currently, the USDA regulations allow food products that contain 95 to 100% certified organic ingredients to use this USDA seal. And these regulations prohibit certain things like GMOs. When a product is labeled 100% organic or just made with organic ingredients, the non-organic ingredients cannot be produced with using GMOs. For example, if a product is labeled like something like made with organic ingredients, they would require 70% of the ingredients to be organic, but 100% to be non-GMO. So hopefully that makes sense. And the thing you'll kind of notice about this is that there are sort of these nuances to some of these seals. So I'm getting the sign that I got to go quicker. So you should know that there is a specific list of pesticides that can be used, even if it's labeled USDA organic, and those are listed on the website. And sometimes there are exceptions. So seeds may be used that were not organically produced, and if there's no commercially available alternatives, and a couple of other sort of nuanced asterisks. And it's important to note too that organic designation is a process-based system for verifying a farm's product as organic, not a product-based system. Okay, so again, here are some of the voluntary terms that we see on packages. And some of the questions that come up for me when I see these labels on products is, how local is local? What is the radius that would warrant local or not? Or natural, being mauled by a bear is natural. Eating plants like white snakeroot is natural and can cause death. In fact, that's what killed Abe Lincoln's mom. So natural really doesn't have a set definition. Or we could take an example like the non-GMO verified project with the little monarch butterflies. If you go to their website, you can see all the different requirements for using that, for using and licensing that label. And underneath the accurate and truthful labeling section of the document, you'll read that the project does not allow the use of phrases like GMO-free or similar claims because these claims are not, quote, legally or scientifically defensible. So there are a lot of things to consider when it comes to kind of seeing these voluntary labels. And I think that, for the classroom setting, I would encourage you to use this as a lesson plan. Get your kids thinking critically. Enable them to do research of sort of these nuances, half-truths, and sometimes utter falsehoods. So why does any of this matter? So you as an educator have been encouraging students to think critically and ask good questions since forever. And I think now more than ever it is so important because in this era of fake news and fear-mongering, it's so critical to stay focused in teaching the students the value of evidence and science-based information. Some of the world's most pressing challenges will need your students involved in science, technology, engineering, and math. Okay, so Ruth, do you want to add the link for the video?
Yes, Sarah, I have. Would you like to go ahead and have the participants view this video, or would you like them to do it a little bit later since we're running short on time?
Deborah, do you have a preference?
I think on this one, we probably should just go ahead and just leave the link and folks can watch it later. It's just the announcement of the brand new genetically modified apple that doesn't brown, because it just ties into what you're going to talk about in terms of different techniques.
Okay, sounds good. So after you go back and you watch that clip, you'll notice that there are a variety of different reactions from consumers about this Arctic apple. And that's a good thing, because I think that when you're developing solutions to challenges using biological tools, it's important to ask people their opinions, and it's important for food security and food waste challenges. So the particular company in this example listed there, they asked themselves similar questions that we would ask our students. You know, what is the shape of the problem? So if they know that, you know, maybe people throw away their half-eaten apple because it's brown, and then there's a 40% of our food grown in the U.S. ends up in landfill, you know, they have to ask themselves, I wonder if we could use these biological tools to help mitigate some of these challenges. And you know, we can encourage people to buy only what they need. We can encourage people to implement practices like composting. We can encourage people to do things like buy ugly fruit, and all of those things are good. They're all very helpful. But what if plant breeders and molecular biologists could figure out a way to reduce browning in apples by knocking out or silencing the plant enzyme that creates browning in apples with genetic engineering, and creating an apple where practically none of this plant enzyme, called polyphenol oxidase, causes this browning reaction. So keep in mind that there are no simple answers to big problems, and genetic engineering is just one tool in the toolbox of modern agriculture. So I see that I'm running really low on time, so I'll just make this point quick. There are many different ways to get genetic variation, and some of those are listed here. I think that this infographic is really helpful in helping people understand how breeders can get this genetic variation. There is one slight error on this particular infographic, which is the gene editing section. There are actually no commercially available gene edited crops currently. So that's just an error on the slide. The one I want to focus on, though, is really crossbreeding. Crossbreeding is fundamental. Everything really ties back to the power of conventional crossbreeding. And again, you had a link here, but I think you're probably going to have to watch that at another time. I think one important note to make here, though, is that in the clip, they talk about the lack of genetic variation in apples. And that's actually not true. So again, you can encourage your students to stay really skeptical and ask good questions, because, you know, universities like Cornell University have over 20,000 different varieties of apples in their seed bank. So there's actually a lot of diversity. It just depends on what consumers demand and forecasting and things like that. So I just want to point out that one thing. Okay. So in the case of the Honeycrisp apple, as you'll learn when you go back, and the Arctic apple, there are two different ways of going about developing these new varieties of apple. Different ways of solving the problem that consumers had. One delivered a nice, crisp, firm apple, which had an improved flavor profile, and the other delivered an apple that takes a bit longer to brown. One was conventionally bred by crossing two different trees and then grafting onto a different rootstock, whereas the other had been engineered to control the production of polyphenol oxidase, the plant enzyme, by silencing just four genes. One was a product of breeders at a university, and the other was a product of this specialty fruit company. Both are composed the same, compositionally the same and nutritionally similar to other apples, and both were patented. So it's not a well-known fact, but conventionally bred crops can be patented too under the Plant Patent Act in 1930. Okay, so I won't have time to go through this, but there's really exciting things happening in life science. CRISPR-Cas9 system. Which leads me to the end here, just that there are many solutions that need to be developed in order to mitigate the risk of weather, insects, fungus, weeds, soil health, you name it. And we will need the next generation of creative, critical thinkers like the people you are teaching today to develop those new technologies. Thank you, and I'm sorry I ran over the time. We had a lot of content to cover.
We do have a lot of content, and I think the best thing here is to just finish a couple of slides here, as I know there's an evaluation piece that needs to be done. But just highlight a couple of other resources that you might find useful after this video, after this webinar, that you can go check out later. So I'm just going to run through some of those other ideas right now very quickly. And if you have questions, post them in the chat box. As I mentioned, when you go to agclassroom.org and into our curriculum matrix, you can search all kinds of words and find lots of lesson plans and resources like some of the ones we've shared tonight. And in fact, if you typed in the word vertical, you would get vertical farming and what that looks like, and you can see that that's part of this chat box, right, or this keyword search on agclassroom.org. And when you do that, you would find a video on vertical farming, and it would be associated with a particular lesson plan. So when you have a moment to do that, just use some of those words that you can search. You can also search words like GMO or Apple or some of the other concepts that we've talked about tonight. And what you'll find inside of our lessons are very good how to do things with your students in the classroom, and then, of course, associated kits. At the bottom of each lesson, they are linked with the national standards, in this case, a career standards, national NGSS standards for the lesson on genetic engineering that I just showed you the kit for. And then if you want to save the resources, you can create your own account on agclassroom.org so that each time you go back to the site and log in, you can see that lesson, and if we've made any changes or updates, that's updated right inside of your own personal binder on agclassroom.org. Some other things that you might consider as you look through the site with STEM and contextualizing the concepts, some project-based learning things. I think you got those ideas from the teachers, maybe coming up with a better energy bar, maybe using insect flour, maybe doing some more with biofuels and algae farming. We have some new lessons that are coming online for that. Maybe looking at aeroponics and how you could engage students with growing plants in this way within some different types of, in this case, they've got some little banner or some sort of boards up, but doing it in a bucket or some other resource. And of course, if you want to think about doing more project-based with aquaponics, here's a pretty simplified system, and it's something that we're working on agclassroom.org right now. So keep watching our site, keep watching for those lesson plans. I hope you enjoyed the journey that we had tonight, looking a little bit at food ingredients, processing methods, looking at the standards in the production system. Here are some sample lesson plan titles that we talked a little bit about as we went through each one of those units, each one of those sections actually in the slides. Thank you so much to my co-presenters, Val, Sarah, Dieta, and Denise. And if you have questions for any of them, move them over to the discussion, or we're all actually very easy to find on agclassroom.org. We'll have a link to this, and we can also give you access to the emails for these individuals. Thanks so much, Ruth. Back to you.
All right, thank you, Deborah. I'd like to thank our presenters for this evening's program. Our InterAgtion experts are Val Bay, Sarah Young, and Deborah Spielmaker. InterAgtion teachers are Dieta Anderson and Denise Scribner. I'd also like to thank the National Agriculture in the Classroom for sponsoring today's program. And finally, thank you very much to the administration of NSTA for their continued support of web seminars.